Yeah. Okay.
Hello,
I
hello.
decided to do the intro, but I guess I should start. Welcome to this stream. I'm talking about Fusion 360 and 3D modeling of parts for guns. So what's this?
And I'm here to help facilitate the chat room and kind of push any of your questions over to Milan while he's working in Fusion.
I could probably talk a few sentences about myself and why I think I could talk about CAD modeling. I've been in the hobby for a good 6-7 years probably now, and I've started 3D modeling parts about 4 years ago when I had an internship with Blaster Parts. And now I'm studying engineering and design, and that's where part of what I'll try to teach you now comes from. I have some best practices for Fusion noted down. It's probably where we should start, so we're all on the same page. And then I'll talk a bit about freeform modeling or box modeling, or modeling with T-splines, as called. Do you want to tell us something about yourself?
I've just been in the hobby for a good long while, and at this point I've helped several of my friends work on their designs to the point that I feel as though I have a pretty good idea as to what ends up working and what ends up printing well. So sitting kind of armchair with my buddy while he designs things in Fusion, I feel like I have an understanding of how Fusion works, but I've never actually been the one making anything in Fusion. So I feel like I don't know any of the shortcuts or anything. That's kind of what I'm hoping to learn from this. But I'm also just kind of here to help facilitate the chat room actually having their questions answered by you in a timely manner, since you're going to be focusing on the design.
Even if you do that, let me quickly pop up a chat window for my own. Hold on. Wonderful. Okay, so Fusion best practices. To start, Fusion is quite different from some other CAD programs because usually CAD is strictly parametric modeling. You do a sketch, you do an operation with that sketch that could be an extrude or a rotation, and then that operation is dependent on the sketch. In Fusion, that is not strictly the case. You can model without the whole parametric thing, but I think it's the best to use all those features to keep your models as clean as possible. So if you have no idea of parametric modeling, but you are using Fusion, you might not have this toolbar down here. That is because you have sketch history or the model history turned off. Usually you can right-click your model, and then you can tell Fusion to not capture the design history, or if it's not capturing, you can tell to capture your design history. So if I would do that, it's asking me, hey, I'm going to delete all of this. Do you want that? No, I don't want that. Can I go back? Yes, I can. So make sure you have that turned on, because that's where I'll be basing most of this talk on. Okay. Next best practice, it's probably a very, very obvious one, is to start with the big parts, start with the rough shape, and then narrow your shape down. You don't want to, let me pull something up. You don't want to, sorry. you don't want to get lost in a detail, and then you don't want to get lost in detail and have 20 features defining that detail, and then go back to doing the rest of your main shape, and then you want to change something about the first shape because it doesn't quite fit into your assembly, and then you have to redo all those details. So you want to start with a rough shape for your whole assembly or your whole part, and then start adding things like fillets and chamfers, and small aesthetic details. Let me open a bigger project of mine.
So it sounds like all of your designs start very chunky and blocky, and then you kind of shave off the excess to something more aesthetically pleasing.
Something like that, yes. It doesn't need to start all chunky. You can have small parts, but they don't need to be very defined. Close that. This is a pistol I posted quite a while ago. It's not quite out of testing phase, but I only recently got some people back on it, and
I got mine.
Yeah. Good man. Okay. Turn that off. And if I scroll through this timeline, you see there is a lot going on here. And I have some principles in this design, and I've not used some others, and my mistakes became very apparent towards the end. But usually I have tried to keep all the extrudes to the beginning of my whole model, and then I moved aesthetic features like chamfers and fillets more to the end of the timeline. And then at the very end, I started parting out my model into components, so I could make stuff like motion animations. But in the end, this is still, it's quite a clusterfuck. But the very first, or the most important thing, I think, if you want to do such a big design or such a big project with a lot of components, a lot of moving parts probably, is you want to start out with a few very basic sketches that define all your mechanical linkages, all your basic shapes and sizes. So you can see I made a sketch, and then I made a very rough sketch. Then I put more detailed sketches on top of it, so I can reference my very first layout sketch. And if I change one dimension in that layout sketch, changes all the components that reference that sketch. That is the beauty of parametric modeling. But of course, it only works if you do your references right. And to not lose track of your references, you have to keep your model as clean as possible. So yeah, there's some stuff happening here. And you can see all these parts are still in a pretty rough shape. We move on. No rounded corners, no fillets, no chamfers. And you could probably take that to an even more extreme level. You see, at this point, I already started adding some features, but they were kind of necessary to define more of the cutouts and stuff. But I'm just going to leave this alone for now and go. Oh, you know what? There's one more thing I can show you with this model. So I'm going to quickly reload that. And that is one component color cycling. Under inspect, you have this feature, it's component color cycling, and it shows all your different components in different colors. In this case, I already had materials assigned to my whole model. It made them somewhat easier to differentiate. But if you don't have that, and if you have a ton of small bits and pieces, that might be really helpful. And you also see it adds some color to your toolbar, to your timeline. Now, of course, I built all my whole model in one part, and only parted them out at the very end. But it's still a helpful thing if you don't want to, or if you want to have just a little bit more organizing, or a little more accessibility to your bigger components. Okay, now I can turn that off. Now, if I want the color separation in my timeline, but I don't want to look at this mess of it, I don't know, looks like rainbow puke. I don't want that. I can just turn on component color swatching down here with your timeline, and boom, I have the same colors here. Now again, in this model, it's not very apparent because I did it all in one go and then parted it out. But it differentiates the features by colors. And if you are working in multiple components in one part, then you definitely want to try to keep the features of each components in groups together. Another helpful thing is to organize, once you keep them together, to put all the features that belong together in a group. So if I have a bunch of radii and fillets that I want to keep together, I can mark them and create a group. It keeps my timeline just a little bit cleaner. Okay, now nope. Next up. Now this is a bigger thing, and this is how to really enforce that structure that I talked about just now. If I have like my rough assembly, let's say I had a small layout sketch and I made multiple components of that sketch, and these components reference each other and they work together, so I don't want to create them as separate parts. In this state, I can go into my layout sketch, edit the sketch, and move one of the components, or edit some dimensions, which of course mine is right now not fully defined. I could edit some dimensions, and then that of course changes my part. Now, if you could turn your components into parts, that is by creating a new component from body, select the body you want to turn into a component, and that works. Now you have a component here, but if you go into that component and add some features, let's say I want these side corners rounded. Now I have this feature in my component, which sounds like a good idea. It doesn't pollute my main structure, but oh no, it's also in my main timeline. So if I now start parting out my components and adding various features in this component, then I go into that component, it's going to fill up my whole timeline. I don't want that. So what do I do instead? This is a derive, and I think it's a feature that very few people know. Usually you just use it to take just a bit of your part, just a small body or a component or a sketch, into another part that has nothing to do with the first. So I save my part, then I use derive. And now I'm doing the same that I would do with making a new component, but I am not putting that component into into this part, I'm going to create a new component that is separate. Let me get rid of this component. Okay, so derive. So continue. Yes. Create a new design, model objects. Now, let's say I want this linkage, and maybe I have some. I want to add some features to this linkage later. So just in case, I'm also going to derive my master sketch. This is important because otherwise, I might have as well made the component from scratch outside of my assembly. So I'm also importing the sketch, and I could also derive things like my origin point, but I think I don't need that. Now this is my new part, and you can see not only got my part, it's also got the master sketch, and now I can add things like, now I could add a new sketch here and maybe put some knobs on here to interfere with my other components. Let's not save this, but I have prepared the same in the test file. To that. Ta-da. So I have all three parts parted out right here. I can see it has this linkage warning. That just means I changed the original document, which is this, and I can load the new changes. And that's a good thing because it keeps my model up to date. I can still go back to my master sketch in this very first part, change a dimension, and it changes all the components with it, all the parts. So I have this and I have two others. And then I can add my cosmetic details and do more shaping with it. And once I'm good enough, once I'm fine with how it's looking now, I do a new component, and this is where I will do a final assembly of my blaster or bit or system, whatever. And then I just take my parts and I pull them in from my window, from my browser. And you need to have it saved, designed to be able to pull in parts, which I know, of course, because I'm Fusion Pro, but so I can pull this in. Now it's giving me a warning here, but that just means you click on this icon and it updates your references. Now I have more components, I just pull them in. And usually they are designed in place so you don't even have to align them again. They keep their orientation from the first part. But if you need to, you can just do that with the joint command or with move. Okay, take those references. Okay. And the last bit, here we go.
So we do have a question from the chat. Sean says that they've been messing with Fusion 360, but they used Inventor Pro for a while, and they're struggling how to get the dimensions correct for complex parts and how to get the sketches to line up properly. Do you have any tips on keeping the sketches lined up properly and kind of how to narrow down the dimensions that you need?
That's a very broad question. I came from SolidWorks to Fusion, so I probably faced some of the same problems. Sean, if you can try to specify the question, I can probably help you better. Usually I just do sketch dimensions. Let's just...
Yeah, I think that they missed the part with the pistol that you had been working on and how you had those sketches overlay.
So let's go into this sketch. When I made this sketch, I used some constraints, and then if you just press D does dimension, and then you have to click on your part, click on some empty space. Depending on where, it will put your dimension differently. Like I can have dimensions in the X, Y, and Z direction, or I can have just like a length dimension on this line. And once I put it down, it won't change no matter where I pull it. So that's the simplest way to do a dimension. If you add a line, you see it's kind of snaps to some relationships, like vertical, horizontal, of some other points or lines. But that's not a constraint. You see, I added this line, it was snapped here, but this is not a constraint. So if you really want that constraint, you have to click both, and then you can either select your constraint up here, or you can just right click, and it usually suggests the constraints that are fit for this pair of pieces, parts, points. And then escape to get out of whatever tool you are using. This, I don't know if this helped. If you can go into more detail on your question, Sean, just put it in chat and Vlad will probably point me to it. I go back to this now. You see, I already made a change in one of the components. So we put all the components together into this part or assembly. Fusion doesn't differentiate between the two. And I could add some features here, but that would defeat the purpose. If I have them all together here, I can do stuff like add joints, but that's not really necessary. No, I don't want a joint like that. I want a split joint. Something like this. So I can add joints here. I can do stuff like motion links or motion studies, which are a simple way to create animations, so to speak. It's not quite that easy to export them into something usable, but you can render those as well. But if I want to, now that I have my assembly back together, change some of the parts, I can just right-click, open, or open them from the browser, update my references, and then I can go on and work with that. And for example, do a slot, single slot. Like this. Of course, I could try to align them, but I'll just leave it at that. New sketch, extrude, something like this. Add some fillets. Like this. And now we have added some detail to our part. We can go back to our assembly. Not quite. To save our part, of course. Now we can go back to our assembly, update our references, and that change is now in our assembly. And our assembly is still as clean as ever, while it's also still dependent on our very first sketch. And for example, I can change this to 100. You can see it changes not only the length of this part, but also the position of the square. Sketch, updated the parts in here. save that.
It looks like Sean's issue is that, let's see, option to snap the object.
Okay.
360.
Okay, there's multiple things to this. You can turn off the snap to grid here, and I usually never use it unless I have a lot of stuff just to do in empty space, but usually I just don't use it. And I also turn it off. It's not really helpful. So snap to grid, you can just disable that. I would also disable incremental move. Just puts things where they are not supposed to be. And the other thing is, if you do a sketch on your part, you might have the option. It usually puts down sketch lines of all the corners of the face you clicked on. But that's something you can turn off in your preferences. And should be under design, this auto project geometry on active sketch plane. And this is, let me just turn that on. Okay, sketch, do another sketch. So I found this to get in the way quite often. I make a sketch, and now I already have two profiles here. I want to extrude, for example, this rectangle. I finish my sketch, and now I have three profiles I need to select just to get my stupid rectangle. You can, when you're in sketch mode, select these lines and turn them into reference geometry, or just delete them, but I find it easier to just not have them there in the first place. And if I ever need them, I can just select them, and Control P is what I have set up as a shortcut. Just find project under the sketch tools to get them onto your sketch plane if you need them. And if you're looking directly at your sketch plane, you also can snap just to all the lines that you can see usually, or you can snap to all the lines that are on your sketch plane, even if they're not referenced already. Okay, so what I was getting at was we've updated our master sketch. Now we have our assembly, and we can update those as well. Now you can see I did not put constraints on this slot, so it kept the slot where it was before, except for the parallel that I put on there. That's still maintained. If I wanted to fix that, I just go into my part, update it, and then open the sketch and put it where it belongs, or add some proper constraints so I don't have to do that again. That's not quite centered, but I really don't care right now. Okay, we have talked about derive components. Yeah, that's about it for best practices. So let me clean this up, and then I will talk a bit about getting started with box modeling in Fusion, and that's probably a way to make your models a lot more interesting once you're a bit better with that. I should get something to drink. It's been a lot of talking from me. It's quite late here. Would you mind holding the stream for a couple of minutes?
Of course.
Entertaining the stream.
Entertainment is what I do best. Although it seems like we don't have all that many people here that I have to entertain. I know I certainly have actually learned a fair bit as far as the interface in Fusion. That was one of the harder parts for me to get down personally. There's all these tools and they all do something, but I don't exactly know what they do. And actually seeing them getting used has certainly helped me like figure it out. Oh, thank you, Foam Blast. I assume that's cheese on the other end over there.
One thing
there's
that
certainly
really,
some good reference material in here.
one thing that really confused me with Fusion at the start was the differentiation between solid and surface, and that I have two extrude tools, two revolve tools, and all those operations are exactly the same in this workspace, but do quite a different thing. And I can probably talk about these when we're getting further into the box modeling. So, box modeling is an interesting thing. I said before that Fusion is a CAD program, and CAD programs are usually very strict and parametric. Box modeling is quite the opposite. Box modeling basically means we start out with a box. Okay. And then we can push and pull that to wherever we want it to be, and put it into whatever shape we want it to have. And I will explain what I just did there in a second. What comes out of the box modeling are T-splines. T-splines are basically just lines that define the plane that is put through them. So if I pull on a point here, like this, pull on one point here, you can see it changes the whole plane around it. So it's a little bit like working, can work a little bit like you would work in other 3D modeling programs like Maya or maybe Blender, but it's still keeping some of the CAD character. So let's do a small project with this.
It seems a lot more like molding something out of a block of clay.
Exactly. So I've prepared something. Let me save this quickly. And I think we could do a grip, because I've seen too many blocky grips in this hobby. And maybe you can put an end to that. So I put in the reference part. I want to make a small grip that can interfere or that can interact with this bit of caliber and goodness. I've imported my part, I've rotated it, and now I can use point to point to align it. Point to point is a very useful tool when moving. You can select either an edge point, or you can go on a surface and select a point on that surface. For example, if I now want to take the center of that hole for the screw as a reference point, I go on the surface, I press Control, and now I can select this point, and I want to move that point to my origin. Nice. Okay, so what do we do to start a T-spline? We have one here that doesn't belong here. We create a form, and now we're in the box modeling workspace. It's kind of like your sketch workspace, but it's also kind of a no law zone. Okay. I think for this, it's just easiest if we start with a simple box. It's probably the best way to explain you some of the techniques. Let me just go here. If I click on a point, really doesn't matter because what I get in the end is this, and that's kind of easy to do. I want that to be symmetric in the middle. And then I want it to be mirrored. Mirrored, the proper way to pronounce that. I don't want it lengthwise. I want both sides to be identical. And these green lines show that in between these lines, there's an imaginary mirror plane. Okay, so this is my box. Now we want to set up our workspace for box modeling, because there's some tools you will definitely need a lot, and some you probably won't use all that often, or only for very specialty cases. The very first is edit form, and that is usually up here, but the other ones aren't for some reason. So edit form, I recommend you put that on a hotkey. I use E, because we're going to be using that all the time. Next one is insert point. This is really it's quite a diverse tool. It can be used for a lot of things. Next are crease and uncrease, and I will show you what these do in a second. That's maybe it. We can use weld edges. No, that's unweld. We want weld vertices. That's also useful, but I don't think we'll need that in this tutorial. So that's our workspace. And you can probably assign shortkeys to these as well. But I will probably just click on them. Okay, we have our box. If we select a face or a point or what's that? Sorry, it's an edge. Stupid. Okay, if we select one of these, all it basically does is select all the points that are on it. So there's no difference between pulling this face or pulling on both of these edges or pulling on all 4 of those points. And since we have the symmetry in here, if I pull on this edge, it's also going to do the same operation to the other edge. That's super helpful if we just look on it from the side and start modeling. Edit form. This is what we do to get started. I'm going to select this face down here, pull it down, and I get sort of an oblong shape. Probably not quite what I want. Take this face, and now the very first thing that makes the edit tool so useful is extruding. And the way I do an extrusion within the edit form tool is by holding down Alt on my keyboard, and then pulling whatever face or edge, and it will create a new edge where the old one was, and pull the face outwards. Still a weird shape, but we'll fix that in a second. That also works with edges when you are when you don't already have a closed up body. But that's the easiest way to use that for now. Now to get this shape up here, oops, do that. We will select some edges, these edges, and probably this one as well. We are going to crease them. And what creased edges are, they're basically endpoints for these splines. If 2 creased edges come together in a point, they are going they're going on a tangent, or they're going to be tangent. And if 3 or more come together, they're just going to go into a point. Okay, so we have done this, and this looks more like a thing we can put on here already. So I'll grab that down a little, not like this. You have quite a lot of buttons and things here to do when you're using edit. You can use these arrows to translate your part. You can use these to move them in a plane. So right now I'm using only the Z and the Y plane to move this. And you can scale. You can scale in one direction. This is especially useful when selecting multiple things. You can also scale in all directions by using this middle button. Again, this is super useful when you select more than one point. So I've selected this face. I can make it narrower. I can make it longer, and I can move it over. You can select this part down here. And I want to make it longer. Probably want to move it down. And I'm probably also going to want to crease that so we can get a good shape out of here. Now this is looking quite rough, but hey, at least it's got some curves, right?
Gone from a nice egg shape to something that looks like I can grip it in under 15 minutes.
Just move this up. Probably want this somewhat straight-ish here. Okay, this is all the definition we are getting with quite few faces. Now to add more definition, we are going to need more control points. I like to use insert point because it really only gives you all the points you want, and not more than that. There's other ways that I will also show you. Now let me just put some points in here. I select this edge, and this red dot means I am putting a point right in the middle. It doesn't quite look like it, but I'll take it. Let me add one more here, and let me also bring that over. I skipped this side because we're doing symmetric modeling. Now I have a point here, and you can see we have a little bit more definition going on here. And if I move this outward, and maybe this down, we have a little bit more control. Move this down more, maybe even move it out. It looks like a grip shape to me. It's not quite where I want it yet, but not bad. That looks pretty decent. Okay, I want to make this front bit to this part a little bit better. This in maybe. And you can see I can still not really get to the shape I want. So I'll just leave it here and add one more point. So from here to down here. Okay, that's better.
Sean would like to know if you can do the ribbing like on Nerf blasters this way by adding 2 control points and just pulling them in. You mean like the waffle
like a
kind
seam
of bit?
line, like a seam line, or
I think he means the waffly bit that gives you some grip on your palm.
Okay. That's probably something that you would add after you did your model, like after you did your box model, because these the way T-splines work is they give you basically the sleekest way to continue to put a continuous curve through, for example, these 4 points. And if I add more points to this, if I put a control line here, one more here, one more here, it's going to piece up this curve into it's completely going to over constrain that curve. And if I change some point, I have all the other points here, and it's going to create like a bump out here.
This is on the back of the handle, like on the back of the rapid strike. I think that's something that you would still wait until the final
Yes.
aesthetic touches.
That's actually one of the key parts to this box modeling, is to keep it as simple as possible for as long as possible. So right now we're still at let's say 3, 6, 9, 12 plus 2, 14 squares. That's nothing. That's good. I want to add a curve here, so I probably need one more. What I'm going to do is select this edge. I'm going to put an insert edge in here. It's not quite doing what I want. It's really not doing what I want. Let's try that again. I'm going to take this edge, insert edge over there. Now I can slide it down from here. Okay. There we go. You can already see I have more points here, and this curve is not looking too nice. We can fix that, but the more points you have, the more fixing you will have to do. So let me move this down. Let me maybe select this and bring it in. And then we still want an edge here that he didn't create, that I didn't ask him to do. Just put it over here. Okay. And then maybe just move this in a little. Maybe move the whole bottom over to the back. Something like this. You can see how fast I can change the shape in this stage, in this. Maybe make it a little longer. I don't know. That looks decent to me. Now maybe I want to add a little bit more of a curve here, and you can also see it kind of changed everything up here with it. So there's a lot of going back and forth. Let me add another line here. You can really get lost into this in this modeling stage. This looks about like how I wanted it. A little bit more round on the back, a little bit more square on the front. Now, if we wanted to add, for example, a notch for your middle finger, you can probably add a line here. I messed up. Probably because it added 2 lines, one for each side. So just put one here, add the second, put another one here. Same mistake again. Don't be afraid to use Control Z doing this. And you can already see what this did to my shape again, because I gave it more points that it needs to follow. Let me slide this up a little. That didn't do a lot. And here's a finger notch. Take it or leave it. Of course, there's probably more elegant ways, and you can play around with this for quite a long time. What you can kind of see is that this line is quite close and still doing the arc over here, and this line has quite a distance, but I can't really pull it up further, or it'll just fold in on itself. That's because we have quite a big distance here, and that's giving this curve quite a bit more weight. It's trying to change from this very straight piece of curvature into this curve, and it's only slowly getting where it wants. So this is good enough for me. Of course, you can add more constraints and really define your model if you want, but keep in mind that the fewer control points you have, the cleaner your curves will look. Okay, I'll just keep this as it is. Now, to make mating our parts easier, I'll take this face and move it slightly. You know what? There's one thing I'll do first. Let's make this face flat. Make sure all points are on one plane, as flat as possible. I'm going to use flatten. I have all my points selected. And now I have the option to make them just flat in the orientation they are in. I can put them on the plane. For example, this one. That didn't work out too well, did it? No, it didn't. So we're not going to do that. Or I can select a parallel plane. Nope. It works. Where does it work? So I think it's probably having some problem with the symmetry. So that's usually how you do it. Probably need some troubleshooting to get that done. Nonetheless, let's take this. Let's take this. Pull it just slightly beyond that plane. There we go. There we go. That's good enough for me. Once we finish that form, you can see we have a body, and that's our grip shape.
Lightning Eagle was asking what tool you were using to just drag the shape like that.
That's the edit form command. Now, what's important if you want to go back, I'll show you that in a second. You want to go back into your piece, into your part, into your T-spline box model form. You won't get there with the create form command up here. You need to go into your model, right click, and edit, just like you would with a sketch. It's this one, it's edit form. Sorry. Okay. So to make this fit, I'm just going to do some very quick. We'll create a sketch to cut off this curve, and then we are going to use the intersect or combine function to make that model. Skip these. Connect them with a radius. If you are drawing lines, that's like a quick tip. If you're drawing lines and you want to create a tangent arc at the end of your line, you can go on that endpoint and hold and drag and hold, and you're getting this tangent arc. Okay. So that's what I did in here. Tangent. Probably I'm going to extrude this with a surface tool. So on the surface, extrude. This allows me to extrude lines and not sketch profiles. I want them symmetric, just like this. And we want to use this to cut off the excess from our body. So we can use the split body to split, our grip, splitting tools, select this, and we can extend the splitting tool automatically. And now we have this waste bit that we don't need, and we have a clean cut and two perfectly straight faces. And now we are going to combine. And this is where all your Boolean operations are. Target body, tool body. This is already set to cut. Might also be that it's set to join or intersect. Make sure you have the right one selected. And if you want to keep the component you have selected as a tool, you need to make sure this box is checked. Right now that part is part of as it's linked to another file, so I can't delete any bodies from it. Okay. So now you have this cut off. We see we have a little bit of junk here, but should just be able to select them and delete, get rid of most of them. Usually delete is quite good in Fusion. Okay, we're almost there. To make this actually fit on the Caliburn part, you probably want some tolerance in between. So we are going to use the shell command. We're not going to use the shell command. We are going to use the offset face command. I get those icons confused all the time. So like all the faces in here. And we're going to give them something like negative 0.2 millimeters or something. And that's going to be it. Now we could also add all the things necessary to add a screw in here. We also already have like this entry point referenced with our origin, but I'm going to leave that as be, as it's not quite the topic of this. Add maybe another. Let's not do a filler, let's do a chamfer to this edge. 5. That's looking pretty nice. I do say so myself. Yes, Cura is probably the best slicer you can use for free. If you have a compatible printer, you could also look into the Prusa slicers. They have some pretty interesting features. And if you have a printer that supports or that has some profiles by default in the Prusa slicer, these profiles will probably get you very far. Okay, we can also take a look at one other model I did using this technique, basically to practice for the stream. And I have one thing going on here that I can show you. It's basically how to make an asymmetric shape from your while keeping your symmetry. So if I go into this part, you see there's some red here, and you can basically do that by it's my toolbar, by isolating symmetry. You can select edges, and it will exclude them from the symmetry. Right now, it has I selected like these 4 edges. It made all these faces red. The only point I can use, I can move outside of the symmetry, is this one right now. So if I want to move this point, for example, I also have to exclude these 2 faces. I'll select these 2 edges. Okay, and then I can take this one point, edit, and move it in, move it up, whatever. While everything else is still very much in that symmetry constraint. But that would be an easy way to add like a thumb rest to your grip, or go a little bit more all out with your design. Okay. What's the time say? That's been a lot of talking. So how's everyone doing?
Lightning Eagle had a question about defining your sketches and how to do it.
Well, you should define your sketches. Were you here, Lightning Eagle, were you here when I showed like the during the first part of my talk, where I had the assembly and constraints explained a little bit? Yeah, let's say that like that. Let me pick this one. No, that's the wrong file. Let me pick this one up again. So if you have a sketch, if you're sketching on the grid, of course, you are getting the basic dimensions right. It's easy. But if you then touch any part of that sketch, it's quite easy to ruin the whole thing by moving it around. So you always have to check back if your dimensions are still right. That's this one. So if I, for example, make a sketch, I'll just stay in this one part to keep it simple. For example, I want to make a sketch on this box. I want to cut out some holes in it. Circle, yes. Do some holes, do some holes, do some holes. That's big. No. Okay. So I made some holes, and I am going to extrude these. Maybe only 1 millimeter deep. So I've added a feature to this box that is, I don't know, maybe I want to mount a pusher on there or something. And now I go back, now I printed that and tested my part, and I noticed, okay, my pusher is kind of too short. So I edit my sketch, I make it a little longer, 10 millimeters longer. And you see it move my box because I have these dimensions added. I didn't have these, I would also have to move the box. But it also lost the position for my holes. And if I had moved even further, two of these holes are completely gone. And usually that's enough reason to complain. I'm surprised he isn't doing that now. But if your feature is, for example, completely off, it wouldn't even complete this extrude, and you would get an error message here. So if you want to don't want this to happen, you should add constraints. For example, you can put in lines. I always prefer geometric constraints over dimensions, because even with dimensions, you can sometimes mess up when you make something smaller. And let's say I made this whole 10 centimeters or 10 millimeters from this wall, and now I make my box smaller. This hole might move together with the other hole. So you could do something like this. These are referencing the corners of my rectangle, and make them construction geometry by pressing X on your keyboard. And that means they are not interfering with the whole profiles. Maybe make this, and then make the holes the distance from a corner, maybe like 6 millimeters. Make your whole dimension radius 3. Or I could also say I want this to be this dimension. And now even if I change this whole diameter, say to 4, it's moving the hole further in, so I don't accidentally go overboard. Now I can maybe constrain these points. Horizontal constraint. Horizontal vertical is always picking the one that is easier for the program to achieve. So if they're almost horizontal to each other, it will pick horizontal and not vertical. And then I could probably also select all these holes and make them equal. Now I can control the position and size of these holes all with one variable. So. And if I change this dimension again, quite a distance, my holes are still going to be there. Cura works well with Creality's large printers. Cura has some very good CR10 profiles and Ender 3 profiles since a few generations, a few releases, and I use almost stock profiles with my CR10. I only changed the nozzle diameter and some of the retraction settings with it. Another helpful things with defining sketches is right now you can see it has this small pen icon on here. I don't know if you can see it in the stream, but you'll definitely see it in your own Fusion. And once I fully define the sketch, so first of all, fully defined lines and sketch objects turn black. So I give these diameter, this size, height. Now my sketch is fully defined. And you can see here, this one doesn't change, but you can see here it has a small locked icon now. As opposed to sketch, as opposed to this one. I really like to use horizontal expansion for 3D printing or for aligning the models, not aligning your models, for making models fit together. I think Simplify 3D has a similar feature, but in Cura, the setting is called horizontal expansion, and you can shrink your model with an offset from its outside wall. And I just have it set to minus 0.1 millimeters or negative 0.2 millimeters. And that basically means the models print at exactly the size that I designed them in the slicer. And I don't have to account for the model getting bigger when designing it. That sounds like a pretty good size, or size. Sounds like a pretty good clearance. Sean, I don't know. I could show you some more advanced stuff with the box modeling or with T-splines and a different approach than using the box and pushing things around. No, I think we're just not talking. My audio is still,
it was time to read.
It was time to read, yeah. Okay. I don't know. Do you know how much time we have left? Still a bit to go, right?
I think the voice in our head will whisper something to us.
Okay. We're probably going a little longer because we started late.
Possibly.
Then I'll just do...
Selected to lead, not read. Very funny, Pandemonium. All right, we still got about 5 minutes.
5 minutes?
Yep, that's what Pandemonium says.
But we started, I think, 15 minutes late. Because this is something.
The stream ends when they cut us off.
Okay. So I think I want to at least try to show you how to model something like this. This is basically my Cybertruck revolver front, but for a strife.
So for this, do you have a base fits in the strife already, and then you just build on front of that?
Yes, I took the base from my Masada. You can probably take one from Thingiverse, or you can take one from Thingiverse as a reference and model your part from there. Okay, so let's start from scratch. New model. I have my Strife connector bit that I'm going to import here once I save this design.
We've been asked why we are wearing the suit, shirt, and ties. I believe that's just last minute shenanigans.
Yes.
Do you have any YouTube channels or websites that you suggest for Fusion, like tutorials and such?
There's some. I think all Fusion tutorials that come up when you're looking for something specific will get you there. There's one very good channel for for the T-spline stuff and for really understanding how that works. One. I'll just, can I copy links into the chat?
I believe that you can.
Ooh, nice.
I would hope so.
Yeah. Oh, that's tricky. My own live stream. Good thing it's not showing that in the live stream. Here's the link. That's a channel I really recommend. He only has a couple of videos, but they are super informative if you're interested in all of this. You can do some crazy shit with freeforms. Like if you ever looked at a car and wondered, man, how did they do that? It started out with this. Then you go back to it into another program to really define it all, but you can get all those crazy shapes and curvatures and edges fading out into surfaces. You can do all that with these splines.
Have you used the point cloud data in Fusion much?
Point cloud data, what do you mean?
David wants to know how easy it is to use point cloud data in Fusion. He has access to a HD laser scanning.
Yeah. So you basically get an OBJ file out of that, or I don't think Fusion can take like raw input from that, but if you can get that scanner to output you something like an OBJ or STL or some kind of surface mesh, then Fusion can definitely work with that. You can turn meshes, or you can turn OBJs or STLs into BREP in Fusion, which is another file format that you can't really work with, but he recognizes that as a solid. So you can cut holes into it or extrude things out of it, which is already really helpful. And you can, of course, reference edges and corners. You can also use mesh files like OBJs, like a scan of a head or something, or of your hand, for example, to then model on top of it, either just for reference, or you can also go into the T-spline workspace and you can snap. You can draw faces while snapping to the object you're modeling on top of. So if I had like a hand in workspace, I wanted to create some kind of gauntlet or some kind of thing that goes over my hand, I can start drawing faces basically right on that object and add a face here and just snap to those points without having to worry about placing these points at the exact three-dimensional space. Yeah. Okay. You know what? Let me try something. If you have a simple STL file, or not so simple, let's take something Caliburn related, something like this. You can, let me just save it first, probably. Okay, so we're not doing the strive bit then. Instead, we're going to do working with STLs. Does it sound good? Open that. What? So this is what it looks like when I just import an STL into Fusion or open an STL file with Fusion. You get this mesh body thing, and you can't really work with that. But what you can do is mesh to brep, new body, and it still looks the same, except that it's changed the appearance. But now you can see it's a body, and if I do, close that, if I do an intersect section analysis, you can see it's a solid. And once you're in brep mode, you can basically select faces, delete them, and if it's a plain face, it'll make one face out of that. Of course, you can't get back curves. Well, that's good enough for me. Sometimes you have to select multiples.
Sean was asking which came first, learning CAD or being a nerfer. Personally, it was being a nerfer.
Yes, but yeah. Interesting story. I got into Nerf when I was 15, maybe. Probably when my parents allowed me to buy my first Nerf blaster. And that not too long after, I got a job with Blaster Pass, like a small internship job thing arrangement while I was doing my degree or my school, whatever, different school system. So you can basically open your mesh file, clean up the faces a little bit, and you have something that you can continue to work with. You could probably select all these faces. No. Select all these faces. If you remove those, you could add a new fillet. So that's how you would reclaim CAD-ish model from mesh file. You see, it's not recording any history of this because it's really not going to help you. But it's still better than just messing. Sorry, still better than just messing with STLs in Tinkercad.
Yeah, that certainly looks like it'd be a lot easier than just throwing something into Tinkercad and trying to mess with it like I've been doing.
Okay. So, any questions?
Any last questions? We're going to be wrapping up here pretty soon.
What's sure.
Let me see if I can pull that up, actually. The voice in our heads has informed us that the Meeker knockout files are going to be available for everybody who's part of the world's largest mod party Facebook group. So if you've got a 3D printer and that's something that you're interested in trying out and building, that would be the place to be.
MGK asks, do you guys sketch designs on pen and paper first? That's a really good question. I depends on what I'm designing. If I'm designing something mechanical, or if I have like 3D reference models I can pull into Fusion, I don't. But for something aesthetic, that's really helpful. So that's actually something I wanted to talk about with this part. Is you can add a canvas to Fusion. It's just like here, insert picture, the canvas. You can select a plane, select the image, scale and position it, and that's how you basically get a reference into Fusion. And then on top of that reference, I would create a form. And for this, the other way of doing T-spline modeling is to draw planes. Not planes, to draw faces. And to draw a face, you need something to draw on. So I'm just going to select this plane, look on it, and I have my reference, and I'm just going to start drawing triangles. In the end, we don't want triangles, but for now, it's just the easiest way to get a clean start. Drawing triangles. Probably messed up. Okay. This again. And you can do this, could do this for your whole surface. And then what you would do, you get something that looks like this. You don't have to be scared of that. You just select all those edges and crease them, and that means the program can have something out of it. So we also noticed there was a little bit of a discrepancy with welded vertices. We can join these points. Okay, so now we have this plane thing. I will take this, move it out, and now to give it some depth, I'll take this point, move it out, and all of a sudden we already have something very three-dimensional. Now we could already start to make this symmetric part, and I always like to use mirror duplicate instead of mirror internal, because first of all, mirror internal barely works. Second of all, mirror duplicate allows you to select an external, to select a plane outside of your object, and it's always going to stay centered to that plane. So now we have more parts, and now we could draw more faces to connect these. This I can see is making these funny curves again, and you can increase those. Okay. Now that's how you would do a big piece like this. And then you can just do some cut and join magic. Split body tool is really helpful. If you want to get rid of a body, you can use the remove tool. That's this one. Right click on your body or component. And with all of this, you can join your bodies together. What was that about the Mika knockout? Madison Nerve. Yes, Mika is giving away the files for his Mika knockout. Meet out to everybody who is part of this mod party group. You will probably post that in the Facebook group, I believe.
Yes, I believe it's in the Facebook group. I believe that we are out of time at this point.
Yes.
So we would, of course, like to thank everybody who tuned in and hopefully learn something from this Fusion 360 tutorial with Milan and myself.
If you ever have questions, of course, please do yourself a favor and Google them first. But if you can't find an answer, feel free to just shoot me a message and ask. I don't bite, usually. Happy cutting, happy modeling, happy nerfing, yes.